Welcome back, guys. We are going to see some previous year questions. NEET முன்னாடி ஒரு last few yearsல எந்த மாதிரி questionல quantum numbersல வந்திருக்குன்னு பார்க்கலாம். We will also see whether we are able to answer these questions based on what we have learned so far. What is the maximum number of orbitals that can be identified with the following quantum numbers? So maximum number of orbitals. So a couple of things that you want to know. Make sure that you guys are able to read certain things. In the orbitals, so you have to make sure that there is plural. N equals 3, L equals 1 means 3p orbital. So I have 3 of them. Okay. So this we have minus 1, 0, 1. So what is the maximum number of orbitals with ml equals 0 means just this orbital. Okay. So the maximum number of orbitals that you can be identified with the following set of quantum numbers is 1. The same question can be asked as what is the maximum number of orbitals that can be identified with n equals 3, L equals 1. அப்படினா 3p ன்னு கொடுக்குறாங்க. அப்ப 3 ஆர்பிட்டலா இருக்கும் ஆன்சர். That's why this is given to confuse you. They are asking about particular one that has ml equals 0. In general, நீங்க 3 quantum number ஓ 4 quantum number ஓ கொடுத்துட்டாங்கன்னா the number of orbitals that you can identify is going to be, if n is given, L is given, ml is given, the answer is always 1. The same question can be asked as what is the maximum number of electrons that can be in an orbital with these 3 quantum numbers, meaning 2, and a spin up one, spin down one. Okay, this is 2014 question. Go to 2013. What is the maximum number of electrons that can be associated with the following set of quantum numbers? Very similar. N equals 3, L equals minus 1. So n equals 3 na third shell இருக்கு, L equals 1 அப்படின்னா 3p orbital, m equals minus 1. அதுல ஒரே ஒரு p orbital கேட்கறாங்க. Okay, மொத்தமா 3 p orbital, 3 of them are there, so 6 electrons possible. அதுல ஒரே ஒரு orbital கேட்கறாங்க, m equals minus 1. அப்ப ஒரு orbitalல what is the maximum number of electrons that can be associated with the following quantum numbers? 3. வெறும் 3p ன்னு கேட்டா ஆன்சர் 6. இது 3p ஒரே ஒரு orbital கேட்கணும், ஆன்சர் is Charlie 3. Okay. Let's go into another year, 2012. The correct set of 4 quantum numbers of valence electron of rubidium Z equals 37. Okay. This is rubidium. So this is first shell 1, n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. Okay. Now let's see. So we are going to have n value of 1, 2, 3, 4, 5. L value is going to be 0 for s orbital, L equals 1 for p orbital, L equals 2 for d orbital, L equals 3 for f orbital. So they are talking about this electron. Let's say the spin is up. Okay. So now we are talking about 5s electron. So what are the quantum numbers possible? Principal is 5, L value is 0, L is 0 na ml value 0 vada irundaakanum, and this is going to be plus half. Okay, now if you see electronic combination 5s1, 5s1 means n equals 1, L equals 0, m equals 0. Okay, so we have 5, 0, 0, half, 5, 0, 0 plus half. Option is alpha. By the way, I don't like to say 1, 2, 3, 4. I like to say alpha, beta, option Charlie, option delta. That way, it's no confusion among numbers. So it is going to be 5, 0, 0, 1. Okay. Going to 2012, another question came. What is the maximum number of electrons in a subshell with L equals 3, n equals 4? Now, when you have n equals 3, L equals 4, you are talking about L equals 3 means L equals 0 means s orbital, L equals 1 means p orbital, L equals 2 means d orbital, L equals 3 means f orbital, and they are talking about 4f. What is the maximum of electrons in a subshell that has L equals 3, n equals 4? So it is going to be 14 electrons. There are going to be 7 orbitals and 14 electrons. Go into 2011 problem. The total number of atomic orbitals in the fourth energy level of an atom is. Now fourth energy level, this is actually a straightforward question. Fourth energy level means n equals 4. What is the total number of orbitals when n கொடுத்திருக்காங்கன்னா n square, that is 16. Total number of electrons would be 32. Total number of electrons with spin up is 16, spin down is 16. Okay, so straightforward. N கொடுத்துட்டாங்கன்னா n squared. You have seen this formula before. Now 2011, another question has come. If n equals 6, the correct sequence of filling electrons would be. Always n equals 6 அப்படின்னா there are two ways to do this problem. One is a long way. n equals 6 னு கொடுத்துட்டாங்கன்னா உங்களுக்கு கொடுத்திருக்கிறது எல்லாமே ஒரே மாதிரி ஆர்பிட்டல் ns 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 எல்லாத்தையுமே ns தான் கொடுத்திருக்காங்க. And then they are giving you n minus 2 n minus 2f np n minus 1 எல்லாமே ஒரே மாதிரி தான் இருக்கு. Okay, so let's write them down. This is the long way. ns கொடுத்திருக்காங்க, n minus 1d, n minus 2f, np. So that's about 6. So this is 6s, 5d, 4f, 6p. Now n plus l rule நீங்க போட்டீங்கன்னா you will actually see that 6x comes, then comes here 4f, 5d, 6p. n plus l rule போட்டு ஒண்ணா பண்ணலாம். But I'll tell you the shortcut. You always want to remember, எப்பவுமே the way that you are going to fill the orbital is always it is going to be ns. எந்த principal quantum நம்ம கொடுக்கிறோமோ அதோட s orbital followed by n minus 2 f orbital followed by n minus 1 d orbital followed by n p orbital. So ns and np அதே ஷெல்ல இருக்கும், n minus 2 f இருக்கும், n minus 1. So s and p கம்பேர் பண்ணும்போது 1 கம்மி d, 2 கம்மி f. So you can actually practice with any of them that you want. Okay, for example, let's say n equals 3 or n equals 4. Easy. Thus this value is valuable. n equals 4 அப்ப என்ன இருக்கணும் 4s, 4 minus 2 is 2f, 3d, 4s. Is this correct when n equals 4? It's actually correct. இதுல எது வந்து permissible கிடையாது அப்படின்னா 2f doesn't exist. So the way you fill it is 4s, 3d, sorry, this is p, 4p. This is always true. 2009. What is the maximum of electrons in a subshell of an atom? Is determined by the following. The maximum number of electrons in a subshell. So எவ்வளவு electron இருக்கும் in a subshell னு கேக்குறாங்க. Okay. Now L value கொடுத்துட்டாங்கன்னா என்ன ஆகும்? So I am giving you L value. Okay. L is given. Now what is the maximum number of electrons? L கொடுத்துட்டாங்க அப்படின்னா ml என்னவா இருக்கலாம்? Minus L passing through 0 to plus L. So totally there are 12 plus 1 ml values, meaning 12 plus 1 orbitals. So we saw in class notes, L கொடுத்துட்டாங்கன்னா number of orbital is 12 plus 1, number of electron is 2 into 12 plus 1 or 4L plus 2. This is with n is given. This is when L is given. Okay. This tells you what is the total number of orbitals, not electrons. They are asking you electrons here. 2009, another question has come. Which of the following is not permissible arrangement of an electron? It's a straightforward question. இந்த கொடுத்திருக்க குவாண்டம் நம்பர்ல எது permissible இல்லை, எது allowed இல்லைன்னு கேட்கறாங்க. Now look at this. n equals 5 க்கு L equals 3 is possible. So first this type of question has come many times. The easiest way to solve is first n L மட்டும் பாருங்க, எல்லாமே permissible அப்படின்னு. n equals 5 க்கு L equals 3 possible. n equals 3 க்கு L equals 2 possible. n equals 3 க்கு L equals 2, this is possible, this is possible. Now L and M கம்பேர் பண்ணலாம். L value கொடுத்துட்டா ml value வந்து minus L and plus L வரைக்கும் தான் இருக்க முடியும், அதுக்கு மேலேயும் கீழே இருக்க முடியாது. So 3 க்கு 0 okay, 2 க்கு minus 2 okay, but 2 க்கு values என்னவா இருக்கலாம், minus 2 ல இருந்து 0 வழியா plus 2 தான் இருக்கலாம். 3 is impossible. So they ask me which is not permissible, meaning this is the correct option. 2007, Seventh question, consider the following set of quantum numbers. Long, பெரிய question but one of the easiest one, which of the following quantum numbers is not possible. We are going to do the same thing. Have a look at it. Pause the video, do it yourself. Then you can look at my solution. As I told you, first n, l மட்டும் பாருங்க. இந்த n equals 3 க்கு l equals 0 possible. n value தெரியும்னா l value 0 to n minus 1 இருக்கணும். அப்ப maximum 1 தான் இருக்க முடியும். 2 is impossible. So this we are asking you not possible. So this is not possible. Okay, n l, so possible is 1 0 possible, 3 2. Now I'm going to look at this one. 0 க்கு ml 0 possible, இது already correct answer னு சொல்லிட்டோம். 3 க்கு -2 possible. 0 க்கு ml value என்னவா இருக்கலாம்? -l to +l 0 தான் இருக்கணும், -1 முடியாது. So this is also a correct option. Now 2 க்கு 3 possible or no? What are the ml values? -2 to +2. So this is impossible. So this is also correct option. B, beta, delta, epsilon. So this is your correct option. Again, try it yourself before you look at the solution. Alright, let's go to something that is much more recent. 2016 NEET phase 1. It's one of the difficult NEET exams actually. Two electrons occupying the same orbital are given and distinguished by. So let's make it simpler. ரெண்டு orbital கொடுத்திருக்காங்க. Okay, they're giving you two orbitals, meaning let's say for example same orbital na, let's take 2p orbital. Sorry about that. 2p orbital. Electrons occupying the same orbital. So this can be 2p x எடுத்துக்கலாம். ஒரே orbital, same orbital. அப்போ 2px ல ரெண்டு electron இருக்கலாம். One is going to be, let's go draw this one here. This is 2p orbital. Okay, they are talking about one particular orbital. இந்த orbital எடுத்துக்கோங்க. இது ரெண்டுத்துக்கும் வித்தியாசம் என்னவா இருக்கும்? n is same, l is same, ml is same. ஏன்னா ஒரே orbital இருக்கு, but your spin quantum number is different. So hence this will be the correct option. 2018 question. This is the last question we are going to solve for the day. Which one of the following is a wrong statement? Actually, this is a lengthy question compared to the other questions that have come. Now, total orbital momentum of an electron in s orbital is 0. Statement ரொம்ப simple. Angular momentum அப்படின்னா decided by the azimuthal quantum number L. L value for a s orbital is 0. So this option is correct. An orbital is designated by 3 quantum numbers while the electron is designated by 4 quantum numbers. That is correct. Orbital you need n, l and m sub l, whereas electron you need n, l, m sub l and also the n sub l and also the spin quantum number. So this is 3, this is 4, so this is correct option. Electronic configuration of a nitrogen atom is this. Okay, now 1s2 is fine, 2s2 is fine, 2p3 is fine. Okay, what you have done is off-bar principle is not violated. Off-bar ஏத்த மாதிரி தான் 1s fill பண்ணதுக்கு அப்புறம் தான் 2s fill பண்ணதுக்கு அப்புறம் தான் 2p. So have you violated Hund's rule? No, you have not tagged any before you distribute one electron each. So off-bar is okay, Hund's rule is okay. Have you violated Pauli's exclusion principle? Not really. Pauli's exclusion principle, no two electrons can have the same set of quantum numbers. இங்க எந்த எலக்ட்ரானுக்குமே 4 quantum numberமே ஒரே மாதிரி இல்ல. So your off bar is okay, Hund's rule is okay, Pauli's is okay. Then how come this is going to be wrong? Now this is where it is. The electron spin of these two electrons is spin up, whereas this is spin down. Now is this permissible? Okay. Now when you look at it, why should I put spin up first? Spin down inga podlam problem illa. But the problem with this arrangement is, remember we saw in quantum numbers exchange energy. So an electron from here can exchange with a degenerate orbital over here. But these two cannot exchange anymore and these two cannot exchange anymore because it is spin up and spin down. So it would rather be spin up so that there is more exchanges possible. So this is not going to be a correct option. And value for m for dg squared is 0. This is correct. So this is 0. This is actually considered as dg squared. I'll give you the notation later for this one. So they're asking you here the wrong statement. Now this statement is correct. This statement is correct. This statement is wrong. This statement is correct. So your option is Charlie. You try to do it after you go through the lectures and try to do it faster also. And in quantum numbers, you have to save time so that you have time to solve more tougher questions like electrochemistry, chemical equilibrium, all those. Okay? Alright. Thank you guys.